All right, let's look at number 17 in section 5.8. We're going to evaluate this integral here. And this maybe in this section, we've been talking about this form, right? The integral of u squared plus 1. And that's going to be what? The inverse or arctangent function, right? So you've got an x squared plus 4 down here. It's u squared plus 1, but we know how we can factor that 4 out. The problem is up top, right? I don't have a constant, right? I've got 46x plus 2. If it was just a 2 up there by itself, we could do what? We could factor the 2 out and we would be in this form. So it's not quite in this form. On the other hand, if it was just 46x up top, that would be just a simple u substitution, because I can let u be the denominator. U is x squared plus 4, and the derivative 2x, well, it's just a multiple of 46x. And so I could rewrite and find the antiderivative there. So how am I going to do this? Well, we talked about this in class, right? I can break this up, right? Split this up into two fractions, right? Over a common denominator, right? 46x over x squared plus 4 plus 2 over x squared plus 4. And now we can do each of these integrals the way we just discussed. Let's look at this one over here. I'll let u be x squared plus 4 so that the du is 2x dx. And I've got a 46x dx, so I'm going to multiply both sides by 23. 23 by 2 being 46x dx. And so I can now solve this. 46x dx will be 23 du, pull that 23 out, all over what? X squared plus 4, which is u. Well, the antiderivative of 1 over u is the natural log absolute value of u. And so we're going to get 23 times the natural log of course, u is x squared plus 4. Over here, like we said, we'll pull that 2 out. And now this integral, what's left, 1 over x squared plus 4, will evaluate this way, but I need to get a 1 here. How do I get a 1? I factor out a 4, which leaves me x squared over 4 plus 1, right, from the denominator. And then I'm going to go ahead and pull this 4. It's not really 4, right? It's in the denominator, so it's really 1/4. Pull 1/4 out, I get 2/4, which will be a half. And now, notice x squared over 4 is the same as x over 2 quantity squared. So I just let u be x over 2, right, which will give me u squared plus 1 down here. I do need to see what the dx will be. Du is what? If u is x divided by 2, which is the same thing, right, as 1/2 times x, the derivative is 1/2. And so du is 1/2 dx, or multiplying by 2, 2 du is dx. I'm going to replace dx with 2 du. Down below, right, u is x over 2. I get u squared plus 1. This 2 can now come out. 1/2 times 2 is 1, and I just get the integral of du over u squared plus 1, right? So the antiderivative, as we said above, is the inverse tangent function, and replacing u with x over 2 gives us that. And so our final result, right, this integral evaluates as 23 natural log. Notice I can get rid of the absolute value bars because x squared plus 4 is always positive, always greater than or equal to 4 for any value of x, and then plus the arctangent of x over 2. And there is our final result. Hope this is helpful.